Hello friends, today I am going to solve LeetCode problem number 81, search in rotated sorted array 2. In this problem we are given an integer array nums sorted in non-decreasing order and it not necessarily with distinct values. Okay, so it may consist of some duplicates. And we are also said that nums is rotated at an unknown pivot index. All right, and we are also given an integer target, and we should return true if target is in nums, else we are going to return false. And we must decrease the overall operation steps as much as possible. All right, now this problem is similar to the problem that I solved last time, which is search in rotated sorted array problem number 33. So in this video I have clarified most of the concepts that we'll be using for solving this problem too. So since we are going to solve it using binary search, so please go through this problem, this video, so that you understand how we are approaching the binary search operation for this problem as well. And in this video I'm only going to um, take into account the duplicate factor in our array and how are we going to tackle those duplicate values. So how are we going to solve this given that we have duplicates in our nums array? So let's begin. I have taken an example over here. So in this example we have a nums array and we have multiple duplicate values of ones, right? And to find our nums, to find our pivot index, so what we should do is we start from the first and we have one, and then what we do is we move next and the values decrease, right? So that is where we know the we found our pivot. So from 0 to the end it's increasing, it's in ascending order. So basically our array here is divided into one half and the next sorted half, right? And we are given our target as 0. All right, so given the target 0, now we use binary search and we found our middle value equals to 1. Now the middle value is equals to 1, so which half of this nums array do we move, do we search? Is it this half or is it this half? So how do we find that? If this was not a duplicate, if there were no duplicate, let's suppose if this was a value 2 and let's suppose all of these values were distinct, then we would know that by comparing the first element and last element. Let's suppose, okay, this was 3, let's suppose this is equals to 2, so then in that case, let's suppose this is also some other value other than 1, then in that case we would compare a middle value with our first element, right? And since in case if it was sorted, first element should be less than the middle value, but this is greater, right? So in that case this is not a sorted half. So since this is not the sorted half, so what we do is we take this half and then we check our target, if our target lies in this half or not, right? So based on that we perform our evaluation. But now since we are given this over here, right, we are given duplicates, so how are we going to solve? If we compare our middle value with our start value here, both of them are equal. So now how are we going to make the decision to which one of the halves to choose to search for our target, right? So for that what do? Is we need to move our start pointer. Since we know that middle value is equals to 1, so that would mean that there are some elements already after this, and we will actually increase, in this case increase our start pointer from here. So now our start pointer has moved to this index, the next index. Okay, so now our start is pointing to 0, and here now we compare our middle value with the start value. And since now the middle value is greater than start value, we know that this is a sorted half, right? And this is another sorted half. Okay, so we have two sorted halves over here. Now we need to find where our target lies. So since this is already in a sorted array, so we check if our target lies within this range or not. Since this range is where our target lies, so our search space is now this, right, in this range. Now in this range our start is this, and we move our middle also to our right pointer to, this was our middle value, right, to mid -1. So our start and end both are pointing to the same same value, and our middle value is also the same. So here we found our target. So in this way we found our target and we return true. So basically that is what we are going to do. If we have a middle value which is equals to the start element, then we increment our start value until we found a start value which is not equals to middle value. Okay, so that's the concept behind this problem with duplicate elements. So now let's solve it. So let n equals nums dot length of our array. Now we need our start. Okay, so I'm going to write down start and then end equals to n-1, which is the last element, and then we need our mid value too, right? So in the while loop, while left is less than equals to, start is less than equals to end, we need to find our mid. So mid equals mat dot floor value of start plus and divide by 2. Okay, now we have mid. We need to check if the middle value nums mid is equals to our target. That would mean that we found our target and we return true. If not, now what do we need to check? Before we check the middle value with the left side value, we check if both of them are equal, we increment our start, right? So our if nums at mid is equals to the start element, that is when we increment our start value by 1 and then continue continue with the next iteration, else if nums mid. So if the middle value is now greater than the start, that would mean that this is a sorted range. So in that sorted range, now we search if target is greater than the start and target is less than mid. Okay, we are going to check with equals to sign 2. If that is the case, that would mean our target lies within this range between start and mid. So we need to shift our end pointer to mid -1, else start equals mid +1. all right, else in case it doesn't satisfy any of these two conditions, then our target lies in the second half of which is also sorted array. So in that second half, we need to now check target is less than target is greater than mid, okay, nums mid, and target is less than equals to nums at end. Okay, so why are we checking only greater than value for mid, and we are also comparing equals to value with the end. Why? Because we don't need to compare if target is equals to mid, because we are already checking it over here. So if target was equals to mid, we would have returned true, but since it is not, so that is why we are doing the rest of the operations over here. And while we are comparing, it could be that start is equals to target, right? We have not compared start with target. So if it were equal, then of course we should check this portion of the first half of our search space, right? And so on for this one too. So if that is the case, then we are going to search the second half here, and for that we shift our start to mid plus 1, else we shift our end to mid minus 1, and that's it. Finally we return false if in case we are not able to find our target over here. So now let's try to run our code and check if it works. Awesome, it worked over here. I have added few test cases, the one I explained it over here too, and the other one is this one too. So now let's try to submit this. Great, so this problem we are able to solve it using binary search and just this addition of these few codes in our previous solution for this problem, right? So that's it all about this problem. Let me know in the comments down below what do you think about it. Thank you so much.